Thank you.
Thank you. So we have the last presentation by Abruzzese, Tiero and Micheletti, and the title is Permanent Monitoring of Thin Structures, and is presenting Abruzzese.
Yes, good morning, everybody. Thank you for this occasion to discuss, even being everyone at home or somewhere else. It's clear. What can you see me?
Yes.
Yes.
Yeah. Okay. So this presentation is inside of a larger project. It's called Money to be Safe project, and then the main idea is to make the monitoring system of the structure. So in this case, we are talking about thin structures, but of course our presentation can be extended. Our work can be extended also to other situations. The main activity we have is to prepare some device, like we can say homemade embedded sensors. So we put in the beams or somewhere else in the shell or other kind of concrete structure, main concrete structure, but of course can be also extended to steel structure. And for instance, we have here some plates. This is concrete plate reinforced, carbon fiber net reinforced. And here on the other side, we have also masonry, brick masonry panel. We put on the test with some typical bending test or shear stress. And this kind of sensors are just skin sensors. And all these kind of sensors are controlled by small, like Arduino-like system. Like here we see a little box we prepare and we test it. And this is a very simple example of comparison between one sensors controlled by our small box and another sensors controlled by very expensive machine. I mean more than 50 times more expensive. And you can see, except the last part is related to the crash moment, collapse moment, all the rest is pretty in good agreement. So this is another test related with the shear test from panel. And you can see here our small device. Devices are deformation devices. And instead of to use accelerometers that give you just an indirect information about the stress, we are using deformation can give some direct information about the stress. So imagine, for instance, a shell with a double curvature and n phi and theta stress. We need, of course, some model to solve this structural problem. But if we imagine to put in one point some kind of deformation sensors like this one, we can have a sort of skin effect. It means membrane behavior, or some other inner embedded sensors can give you some information about the flexural behavior. Now there are some kind of piezo actuators or sensors. Actuators can be controlled by electricity, but can be also reverse. In this case, we are using the reverse way, so as sensors, and then they can give you information about the deformation. We can have some information about the rotation, the curvature, the variation of curvature, and it means also stress. Just imagine some very complicated shell like this one. We are talking here about this as a Aero Saarinen wonderful TWA terminal in New York from 1962. You can see this is not so easy to make some calculation. We are talking about a double curvature shell, and what they are doing now are using a very complicated system like a Rhino, Grasshopper, other kind of assistant design program, and then you can have some idea. But always you need to check your design with some control. So our idea is that if you have some kind of structure, very complicated structure like like this one. This is a tennis center in Hangzhou in China, 80,000 people capacity. This is made by Grasshopper and other system. They call also RIMO. RIMO means a rhinoceros plus model or some other kind of program that control and help you to control the shape and also the structure. You need also to make monitoring. Monitoring is very cheap and nowadays very simple to organize, but we need to use it because in that case you can have a sort of very good control of the structure like you have in your car. In your car you can control everything, your tires, your temperature, everything. Why we are civil engineer, we cannot control our pretty good and wonderful shape made by some crazy architect? Why not? Thank you very much.
Thank you, Professor Abruzzese. And I see that there is a question from Amedeo again.
Where is Amedeo?
Yes, I'm here.
Yes, Amedeo, I see you. Ciao, Amedeo.
Nice to meet you. Thank you very much for the nice presentation, Professor. I want to ask if it's possible to use also acoustic emission sensors that are piezoelectric sensor positioned on the surface of the structure. In this case, you can also localize by triangulation the source of damage.
Yes, look, this kind of system are being used pretty much mostly on the suspension bridge on main cable, and they help you to make this localization. So on. I can never say don't use this or use that. I will use everything you can. Now it's very cheap. It's not very expensive. Okay, acoustic emission is not so efficient in the sense of you need to make a very high frequency recording system to get this information. So you need always to have your ear there, but you cannot do that. So it's related with the number of sample numbers that you get from your system. But in that case, it's pretty useful. So, but if you put together deformation sensors and also acoustic sensors and also dynamic sensors, it means accelerometers, in all this system can give you the main idea, and then you can also make a model that in a real time you can give the real effect of the situation. And most important, you can also record all this information in one database. And even after event, after earthquake, after the shock, after the crash, after something, you can have the information about what happened before. It's like a black box. You can have always somewhere and then can give you some information. I don't know if it's clear what I said.
Yes, thank you so much for your answer.
So thank you. I also have I want to ask you a comment about the economy of permanent monitoring. What are the costs and savings?
The cost, of course, will range in the sense you can have a very nice fur, or you can have just like a fake fur, or just like a wool, or you can have cashmere. It doesn't matter. It's important you have some sensors. In what we are testing now, it's very cheap in our laboratory. We are spending like I can say compared with the past 100 less than the past. It means. If you are going to have a very good monitoring system, you can going to spend 1 or 2%, no more than that, of total cost of the structure.
Okay, thank you. We have also a question by Stefano Gabriele.
One by one, you are getting interested.
Of
Who
course.
is there?
Thank you.
Yes.
I'm here.
Oh, Stefano.
Thank you for your presentation.
Gabriele.
Yeah. Yes, Stefano is the first name.
Yeah, sorry.
No, it's okay. So I would like to ask, because for permanent monitoring, okay, costs could be important, but for this, in my view, much more important is the precision that you can request it to the monitoring, and also how much your sensor is affected by noise that you have in the surround of or in the environment. At the stage of your development, how is the situation about the precision and the ratio between sensitivity and noise of the sensors?
Yeah, this is very interesting question. I can come out with one example. If you're working with wires that are pretty protected, now we can do that. It's not so difficult. We can come out. We can have some very good information with very low noise, and we test in the laboratory with a lot of environmental noise, electronic noise, because in laboratory we have a lot of noise. I can measure with a special kind of instrument a lot of noise, but it affects more electronic device like accelerometers or other kind of things. But these kind of things related with deformation, the cables can protect the signal. And on the other side, there is the communication. The communication is very important because the communication now is Wi-Fi or Bluetooth, or anyway is wireless. This kind of, and that's another kind of field to investigate and discover. But even in this moment, we can be pretty much, we can rely pretty much on this kind of architecture, because even without wait for the 5G, we can have I can say that we are going to have a pretty good structure. I mean, architecture for the device we are going to use for the structure.
Thank you.
Okay, thank you very much, Professor Abruzzese. I wish to thank all presenters of this session, especially the keynote lectures, Professor Brocato. And let's see you again at 2 p.m. So people connected to the Zoom meeting can remain on Zoom, while people following the workshop on YouTube, they will be warned when the new live stream will be online. Thank you, everyone.
Can I add something? So because
yes.
I will be chairing the next session. I will start connecting with to check if all the authors will be present and all the presenters will be present 50 minutes before 2 p.m.
Okay. So see you later. Thank you, everyone.
Anyway, the connection
will be on. So if you can just close your camera and then have lunch.
Or talk, and you are welcome to use this as a chat and exchange and everything.
Okay. See you later.
Okay, thank you very much.
See you later.
Have a nice lunch.
Bye bye.